In the last video, we had this kind of a view where end product was a raster-based contextual analysis using spatial analysis toolbox from within ArcMap, and we used extract by points to actually get the points and the patterns we get now. The technique we're going to use now is Canaries neighbour approach, and usually that's something you can do from within ArcMap. But if you really want to do something on a grander scale, say that every point in the entire part of Sweden, in the entire country of Sweden, and the contexts being something like the 5,000 nearest farms, it is an undertaking that takes quite a lot of time. So we're going to use a completely different software this time. We're going to use the EquiPop software, which is now been around since 2014. Soon there will be another version of it out. But the two versions will be very similar in functionalities. It doesn't really matter what version you're going to use. The EquiPop version, however, needs the material to be gridified. And gridified is like looking and thinking of a raster, that you've got sort of the resolution of the raster, and each sort of cell contains the entirety of values. So rather than having unique points located a little bit everywhere, we force the points to be gridified and located to specific points. Pretty much as the fishnetting technique or anything like that, as you would know from ArcGIS in previous times. So before we start doing any sort of analysis in ArcMap, we will swap to SPSS. You could use any software, where I'll show you what it looks like. So this is the idea. I've opened up the file from that we've got in SPSS. As you can see, all these kinds of things. This is the PPN, is the unique code of the farm, and this is the Swedish letters trying to say yes and no to whether there are farm animals and not. The X and Y coordinates and a specific ID for the locations, and whether they do have pigs and cows and whatnot. So these are the classic material we got from the other one. What we do in this file is that we gridify the material from the X and Y to what we call the X and the Y. It simply is a truncation of dividing X by 100 and dividing Y by 100, multiplying with 100 and adding 50. In both of these cases, it truncates away all the decimals and position the coordinate at the midpoint of 100-meter units. And we can actually see it if we go here. This X value that ends with 13 is now replaced with 50. And this one that starts with 25, ends with 25, sorry, has got 50. So all the variability within the 100-meter unit is being destroyed and instead put to 1 point. But on a Swedish scale, the number of meters, especially when you're dealing with a farm, has got no relevance whatsoever. However, before we can do something, we need to aggregate the material, because in some specific locations there might in fact be more than one farm within the same 100-meter unit. Keep in mind that these are perhaps not original sort of big scale farms. It might be hobby farmers that just have one pig or a few fowls, but they have to report it simply because of infectious disease risks and stuff. So what we will do is we'll start everything by doing an aggregation of the material. I'll aggregate, and I prepared it so far that we got the break variable will be the X and the Y, so that will be the organizer of everything that's being gridified and aggregated. And I've simply chosen, in this case, I'll redo it because this is not pedagogical enough. I'll pick all the values from cows to farms to anything and just put it in the summary, and I'm going to choose, the function sum, because they've got the value zeros and ones. So if there is any cows in any location, the summed value will take care of everything. So for each of the unique X and Y coordinates, we will have the sum of cows and the sum of farms, usually just one, in some instances perhaps up to 3. And I'll give this a name. In this case I'll call it farm ag, and I click OK. And this is what the material looks like. I've actually redone it after you saw the video, so I've also created something that could work as an ID variable. It is the number of the first occurrences of any farm located, and that location has got a unique ID. This is it. Otherwise, the same material as you saw in the aggregation phase, the X, the Y, the sum of cows, the sum of pigs, and so forth. And if we scroll down, you'll see that at some point there we do have a location here where we seem to have two sort of farm locations in one spot, but only sort of the sum of one cow, which is interesting, but nevertheless. So this is how it works. So for the majority of cases, only one occurrences. So this is what we're going to do. We're going to export the material into a text file, a tab delimited text. We can call it farm animals. And I am going to locate it here. And let me see, I'm saving it as that, and the translation is ready and done. When I do this, again, let me see, I'm going to, in fact, rename it from tab to txt, because I find txt easier to work with. It's got nothing to do with any specifics more than my wish for how to work with it. The software EquiPop will work with both. Now, let's move to the EquiPop software. The EquiPop software looks like this. I'll drag it out so we can see the majority of the things. It's very easy to operate. Let me see. It's easier to see if you can see it. So I do open, and we browse for the input file. And the input file in this case would be located here, video, GIS2, point primer, part 4, farm animals, and I open it up. What I need to do is to assign the various functions that are found here in the field category to the variables. So I'll drag and drop ID to the ppn first, the ID of the farm, the east-west to the X, north-south to the Y. Count all is the farms. It's simply the count of the total count of something that you want to use. And the count subgroup is, in this case, the pigs. We want to find out the share of pigs. The others, I need to render the value of the function none, so they are not included in the material. So all these need to be sufficed like that. I can enter the rectification unit since I know it. It's 100 meter. If I don't, it's being automatically detected. When I click OK, the material is being loaded. What I now do in the reporting intervals up here is that I define the number of Ks that I want to study. And the beauty of this software, it can do so many at the same time. I usually do doubly sequences with this, so I'll, even though it's not exactly doubly sequences, nevertheless, 12, 25, 50, 100, 200, 400, 800 farms. So we'll find out the number of pig holding units among the 12, 25, 50, 100, 200, 400, 800 units, which is quite a few. We can actually even go for 1600 and see if there is any good pattern. And that pattern is then studied for any farm located anywhere in the country. So this is not distance based, it's more or less K-nearest based. What you can do in addition to this, you can also have, and I have to move up a little bit, you can also have decay parameter, exponential, normal, square root, log, normal, and power, if you know the decaying form of the thing, so you've got an idea about the decay. Because what the k-nearest neighbor approach is doing, it is that it starts with any specific unit, any specific coordinate, and it counts the ones as neighbors, and it stops when it reaches, or it reports at least, when it reaches 12, 25, 50. If you do think that distance is an important decaying factor, you should really add that as well. In this case, we'll keep it simple, and we'll simply just run analysis, and the analysis will take care of it without any distance decay. We'll hope to be able to see this very quickly. Let me see, I'll pause it in the meantime. It will not take more than a few moments before it... Well, it turned out to take a little bit more than a few moments, simply because there are relatively few cases for the entire country and farms are well spread. And with the fact that it's looking through all the hundreds of meters through the territory, it means it takes some time. So in this odd case, it would be quicker if we had 1 million points, but since we've got 40,000, 45,000 points, it actually took a long time to find the 1600 nearest. So that's, I don't know, something like 1 hour away from when it became final. It's more than just a short one. But it's got to do with the composition of the data. Well, so in order to get this material working, as you can see, if I hold my my cursor over it, you got the pop-up information about what kinds of choices I've made, the K values, the rectification units, and so forth. But if I click it, it enters, let me see, it enters a web page where I download the material. By the way, this could be interesting because this is the web page where where you can download the material. You click the download. All these other kinds of manuals and extras and references, and also decay computations for those who are interested in that, are available in this kind of material. But that's for you to find out. Here we've got the farm animals. Let me see. You can't see it. I have to do. Let me see if I can change this. If I do this, you could see that I can. Fortunately in Swedish, this is a map, which means show in a map, and then I could copy the material and I can move to where I want it to go, which is in the video, GIS 2, and in the point primer and part 4, and I paste it in here. And when I've done that, I can simply extract all. So I'll make the same kind of material be available, so you can see it here. Then we've got the metadata file. It contains all the information that sort of describes what we've got in the material. And here we've got the material, which is too big to double click because it's 9 megabytes, and a text document will take some time to open. It's completely uninterested. So what we'll do is we'll drag and drop this directly into ArcGIS, and we'll see how it works and behaves there. So going to the ArcGIS software, we use the same as we did in the third video, part 3. This time I'm going to refresh part 4, and as we can see, it now gets a plus. We do have farm animals, and I can drag and drop the farm animals results. If I now right click on this one, and I'm sorry, this one I have to do like this to make sure it works, and you can see it, display X and Y data. And then I choose east-west as X and north-south as this one. And in this case I'm fine with the SWIREF because these are the coordinate system that we got in the material. And I click it OK, and I click OK again. And I simply wait for it to make all these points visible. And it shouldn't really sort of be much of a visible difference. As you can see, it just covers the old dots because the original spots are still there. But if we, let me see, if we go up to the top, and if I may zoom out, and I'll hide the farm count values, and I'll have the pigs from the last episode, and I'll also take this one away. So the only thing we got going, let me see, there's still some of these materials visible. Yeah, there it is. Now only the points are visible. If I go for properties, and I wait for it to come along, it takes a little while for it to think. There it goes. And I go for quantities, and I've got the different values that I entered as K values. If you remember, if we go for this one, let me see, this one you saw we have 12, 25, 50, 100, 200, 400, 800, and 1600. If we now go back, you could see the same kind of values repeated here. Interval ratio 12, 25, 30, 50, and so forth. These are the shares of pig farms among the 100 nearest neighbours, among the 200 nearest neighbours, 400 and 800. If we go for 800 here, for instance, it thinks for a little while. We might need to do a sampling to find a bigger seed because we've got more than 10,000. We've got something like 45,000 farms. I don't remember the exact count. And these are the distributions. So if we are fine with the natural gengs, I increase it to 10, press OK, and I press OK again. We could see that this is the coloration, and I immediately see that I need to take out the circles around the material. I might, by the way, do a zoom in so we can see more of a pattern. This becomes a very indicative way of looking at it. Rather than looking for the sort of the RADI base, it says something about the 800 nearest farm. That means that for any specific farm, this one over here, it looks for the 800 nearest farms to see how many of these have got pigs, and the same number goes here. So regardless of the geography, it always finds the 800 nearest. If we go for a lower number, we see it takes a while again to make it think. Sorry, let me see. We go something for a lower. Let's go for an interval ratio 100 instead. We have to wait for it to actually go through all the values and see if we got any unique ones, and then I click OK, and we can see, given that we got a smaller count of neighbors, it becomes a little bit more detailed. There's a little bit more variability. And if I do this again, I'm sorry that you have to wait for these sort of the computer to respond to my things. If I go for I control everything, and I go for properties for selected symbols, and I minimize the size, and I'm going to take away the outline color, and I'm going to print OK. Now everything's brown. I'll go for blue to red instead. And here we get a clear kind of depiction of the colors, maybe, and especially if we work like this, if I put the full globe so we could see the pattern on an all Swedish level. It might be easier if I, from this perspective again, I mean this is the 100. If we go for something detailed, and thereafter we go for something really big scale, and we can see what it is. In the meantime, as it waits, all these values then are saved into the text file or into the dbase files if you want to. Those could be used in regression analysis, or all kinds of values, or even being used to interpolate. So the values and the colorations are only corresponding, in this case visually, to what we see, but in fact you could use it statistically in any which way. Now, being zoomed in, you can see this is the K level of 25. We see much more detail. If we again do something for the biggest scale, we'll try to see if we can remember it. It's really slow today, the computer. I'm sorry for that. So finally, we go for interval ratio 1600. We just have to wait for it to accept all the settings. And if I do this and I click OK, we can start seeing the change in pattern. Here we see at the larger scales, if we go for so many, we got large scale things. So why do we think this is important? Well, if we think there is a sort of a need for a veterinary clinic among larger counts, and these ones, the red ones we can see in these areas, we've got something like 14 to 17. That means percentages, in fact. So 14 to 70% of all the farms have got pigs. Just do the multiplication with 1600, you realize there are quite a few in those areas. It might be indicative to where you would need a center for veterinary services or food supplies and stuff like that, which is really kind of an interesting. You can also see the patterns on a larger scales and make sort of assumptions on what kind of farm and cultivation culture or regional compositions or whatever you need are available at the local spot. So these are two different ways of looking at sort of contextual analysis. The part 3, the radius based, and the part 4 on the k-nearest neighbor approach. We just go for the graphics, but it's easy to move from here to any statistical or geocomputational analysis that would follow from this. So thank you for this. That will be the end of the part 4 of the point primer analysis.